This is turning into a freak show. Hello viewers, today we will be cleaning and servicing a Honeywell pedestal fan. The information's, let's see, it says it was made in 2006. I think somebody said the informations are under the base, and that is correct. The model number is HS-1750 series. So let's switch this on so we can get a sample of how it runs before, and then we'll get into taking it apart. It's actually moving a decent amount of air still, despite all the dust. Doesn't sound too good though. I want to grab that startup sound too. Bearings sound dry, but they seem pretty free still. Alright, so let's get this thing apart. Pedestal fans are always kind of difficult to work with because the studio doesn't really fit them that well. The guard comes off with the clips. No pesky screws like you see on the fans of today. How easy. The inside of the guard. So we'll get that cleaned. This is extremely brittle. I must have made this out of a different plastic. This plastic is much more sensitive to the sun. Kind of an interesting texture in there. That's extremely brittle. In fact, it's starting to crack a bit there. The good thing is the threads are metal, so at least that won't be breaking. And is that a washer in there? Kind of looks like there could be a washer in there. No, I guess not. There's like a second plastic piece in there. It's kind of strange. In the initial checkout, I mentioned some concern about the blade being warped, and while it's not terrible, the blade is definitely starting to warp a little bit. Fortunately, it's not enough to the point where it's going to significantly affect the performance, but it's definitely a little bit warped. This is a good view right there. You can see this is just ever so slightly bent. It should be like that. But I'm not really sure how to fix that yet. I've tried a couple different things and it didn't work out too good, so I'm not going to do that on something like this, which is pretty uncommon. That's loose already. And this is also that brittle plastic, so I have to be very careful when screwing that back on. Okay, rear guard is off. Oh dear. Look what we have here. We have some crazy screws. We have what look to be hex bits. And there's like something in the middle of them which may prevent the driver from fitting in there. No problem, no problem. I've got every bit under the sun in the studio because unfortunately these crazy bits are becoming a common sight. Let's see what we have here. Looks like it's going to be this one. Nope, too big. I've been screwing screws for a long time. I should be able to tell this better. There we go. There's only one size off. And the hole is the it's hollow in the center, so it'll be fine. Not how cheap these are made. The stinking hole isn't even centered on the bit. Chinese garbage. Unfortunately, with all these crazy bits, because there's something of recent creation, it's hard to find vintage bits with all these stupid, crazy sizes. Anyways, let's proceed. Should come right off. Really don't understand why they do this, because you know, if you get someone that's inclined enough to open the motor housing and clean and oil the motor, they're not going to be stopped by a weird screw. Okay, here's the inside of the fan. Nice motor. Good size, very clean. Well, from the front anyways. I'm sure the back won't be quite so clean. Okay, at this point I think I'm going to remove this from the base because it's just very awkward to work on it like this. Okay, that doesn't seem to want to come off, so let's try taking it off at the top instead. I'll just try to there is this here which looks like that may release it, but this is brittle plastic. I'm not sure I want to try that. I think the safest way to do this, although this may create some annoyance with the tilting mechanism, I think the safest way to do this is going to be to just undo it up here. And I'm sure the tilt mechanism will come flying apart, but I'd rather deal with that than cracked plastic, because I can figure out a convoluted tilting mechanism. I can't figure out cracked plastic. Okay, I'm trying to do this slowly so that I can see how this tilting mechanism goes into place. Looks like it's very simple. Very good. Okay, it is simple. It's just a basic spring. Alright, so now we can set this aside for cleaning. And in fact, let's also separate it from the base if that's possible. I'm not sure if that is possible or not. Let's find out. And it may not be possible. Don't think there's anything holding it in. I don't see any kind of screws or anything like that. I kind of think that it should come off. And if it doesn't come off, what a pain in the neck it's going to be to try to clean this. I think half the problem is I can't get a good angle on it. I don't want to push my luck with this too much because it is brittle plastic, but let's see if I get a good angle on it. Can I get it to come off? Oh, it's not even budging. Well, actually no, it is. Okay. There we go. It's off. I don't understand how it was held in. I guess just friction and a little bit of rust. Okay, so now we can clean this a little bit easier. I just saw this on the floor, which is inherently part of the tilting mechanism. It must have flew out when I pulled it off. It's a good thing I saw that. That would have been bad. It just sits in there like that. Okay, now let's get into the motor. We have another cuckoo screw in the back. It's fine, still got the bit on the drill. Different screw, same stupid bit. Okay, now the oscillation mechanism is made of very brittle plastic, and you can see here in the corners it's starting to chip off. Unfortunately, there's no way to get this off besides to just pull it off. So hopefully it'll be okay. The motor housing itself is very brittle plastic as well. You can see it just flaking off. Not good. I can't exert the amount of force I need to on this motor housing anymore. It's just too brittle. Now the oscillation mechanism itself is metal, so maybe I can put something in there and hold on to that instead. Nope, that's not having it. I'll try to tap it off, maybe. Guess we're entering kind of dangerous territory doing this, but I think no matter what we do, it's going to be a little dangerous. Okay, that worked. Or did it work? It broke. That's going to be an issue too, I think. Well, it is and it isn't. This is very easy to fix. I'll just put this in here and I'll fill this thing up with hot glue and it'll be as strong as it ever was. Would rather that not have happened, but unfortunately, when you're dealing with brittle plastic, something almost always is bound to break. So we'll just have to repair that. Okay, now the switch, I think the switch just pulls off. Although this too is very brittle and concerning. Thought it would just pull off. I don't know why it's not. I can hear it creaking. That's not good. Alright, that came off and it didn't break, so that's good. Here's our motor housing. It's definitely got some brittleness to it for sure. But it survived. So now we're left with the motor. It's a nice all metal motor. I'm sure the oscillation gears are the plastic, but everything else is the metal. And this is designed not too horribly. It is cutting into that screw edge there, so that's kind of stupid. But it hasn't even worn through the jacket yet, and this has a lot of hours on it, so I think that's okay. These oscillation fans are always a little flaky when it comes to the safety of the wires, because you're dealing with wires that are moving, and anything that's moving eventually wears out. So it's one of the reasons why I don't like to use oscillation fans and oscillation. There's just too many things to go wrong. Okay, so now that we've got everything disassembled, I'm going to start cleaning the plastic parts so that they can dry while we're servicing the motor and repairing the oscillation control thing. While the plastic parts are drying, let's take a look at the motor and get this serviced. It's not too dirty, which is nice. So I'll get one of my ticker towels out here. And the first thing we have to do is remove this thing from the shaft that prevents the blade from going down all the way. That thing has to come off. I usually just take a plier and pull that off. Okay, and now we have to clean the shaft off so that it doesn't have all that dirt on there. And the easiest way to do this is usually just to turn it on. Oh jeez, don't want it on oscillations. Okay, so the shaft is pretty clean now. There is a rust spot on here, right here. So I'm going to take a sandpaper and go over that shaft. Don't have to do much because it's not that bad. But I don't like to have any kind of abrasion transpire to the bearing when you slide it off. This is a pretty fine grit sandpaper. You'll see as I go along here, you'll see the shine be restored to the shaft. Okay, so now that's nice and clean, and it shouldn't damage the bearing as I slide the bearing off. Okay, next we're going to brush off any excess dust. Appears to be a little bit on the top here, and around the capacitor and on the back, and the oscillation mechanism. A otherwise it's pretty clean. So that's that. It's good enough. And now I think we're going to have to cut this tie wrap off. Let's unzoom this a little bit. I'm going to cut that tie wrap off because when we separate the... is that necessary? Yeah, it is, because when we separate the motor... yeah, it is, because the windings... The wire is attached to the front, and so when I separate this piece has to be able to come this way, and it's not going to if it's attached to that. So we'll cut this here, and I'll just glue it back together afterwards. So we have 4 screws that are going to release this around the outside corners of the motor. Got a bit that fits, and that's a good one. That's a better one. And we'll pull these screws off. Usually these screws are on too tight. These were at a good tightness. Okay, now we'll pull those out. And looks like this will separate pretty easily. So now in this case we also have to undo this screw to release this mechanism here. Whoops. This is not going to be easy. Usually this is inverse threaded, but that one was not. Okay, and there's a washer in there, we'll take note of that. And now this will come apart. Pull the shaft out of the back first. Separate this. And now this should come off with no resistance. If I hit resistance, I stop. Good. So now we can clean the shaft and the front bearing. And in this particular case here, this is going to be a little bit more difficult because the wire for the windings is passing through the rear motor housing. And so without an outrageous amount of, well, unnecessary amount of effort, we'll not be able to get this to fully separate. And I don't want to just pull it up like that, because if the winding starts scraping against the rear housing, the insulation could come off and then we'll have a problem. So I think to get to the rear bearing, I'm just going to remove the oscillating mechanism and go in that way. And of course this is going to require the removal of multiple components. And the disappearance of a screw. Okay, that's not good. Not want to be putting that much force on the windings like that at all. That was terrible. Let's try again. I'm going to hold it a little better this time. Okay. Pull that off, and there's the rear bearing, so we can get right to that and clean that out. Looks relatively clean in there, but I think there is going to be a little bit of dried up lubricant. There usually is, because sometimes the grease from the box gets in there, and then that'll solidify and harden over time. A little bit of it in there, but not too bad. See right there, that yellow stuff, that's the oscillation grease that got in there. Now, problem is when we slide this shaft back in, it invariably is going to get some of the oscillation grease onto the bearing. It is what it is. These are all spinning freely, so I'm not going to worry about that. That's good. A little bit of wear on the shaft there, but it's got a lot of hours on it, so that's not unreasonable. It's spinning freely, so I'm not going to worry about that either. Now we'll go into the front bearing and clean that out. Front bearing may be totally clean. Pretty much. Alright, so now let's put the oscillation mechanism back on. Now this has a lot of play to it, which I don't like. It shouldn't be so loose. Try to approximately center it, I guess. If we run into any kind of an alignment issue, that's probably where it's going to stem from. This is a 3 microfarads capacitor. I have suspicions it may be on its way out. Okay, now we're going to put some oil in here. There's two kinds of oil that we can use. The first one is the blue can, 3-in-1, not the red can, not the red and black can, the blue and red can, because this one is specifically for FIANs. It says it right there on the box. FIANs. Okay, the other one that we can use, and we're going to use it in this case because it's easier to get in there, is the zoom spout. And this is specifically for electric motors. Electric motors, as in a FIAN. Okay, so what we're going to do is we're going to put a few drops of oil into the wick. And we're going to do that on the front as well. Okay, it looks like that has soaked in. So now we'll put a little bit of oil onto the shaft itself. First I'll put the front half in. Okay, and that's spinning freely. And I'll put a drop or two on the rear. And we'll slip this in, and again we're going to be very careful to try to avoid getting the grease that's on there onto the bearing surface, but it is just about inevitable. Some will get on there, but we'll avoid it as much as possible. Okay, so that's on there now, and just goofed because this wire needs to be on this side. Now the shaft has slid through there twice, which means twice the amount of oscillation grease is on there. Having some alignment issues here. Okay, what is going on with this? Why that wire is so tight compared to the way that it was before. And I'm going to slip that. Where did the thing go? This back in here. And yes, I am cheap enough that we're going to glue this back together rather than replace it with a new tie wrap. Because quite frankly, there's no reason to replace it if you can reuse it. Oh, that wasn't even in the frame. That's all set, just as sturdy as it was before, or maybe not quite, but it's good enough. Now we're going to put the screws back in. Start with this one on the oscillating mechanism. Okay, and the other 4 screws. Okay, all the screws are back in, Now the shaft is relatively free, but to align it, we're going to take a screwdriver and strike it a couple of times. And now it's in good alignment. Okay, and we'll reattach this piece. Okay, the motor is ready to go. This is turning into a freak show. The lens cover is not open. The label is just exploding. This was on the drying table and I put something on top of this and it broke through there. And then as I was screwing it off, it just completely busted apart. It's so brittle, it's ridiculous. And I didn't realize it, but I should have noticed it because, I mean, look at the edges, it just breaks apart. This stinks because this is in the center of the fan. This is the first thing that you see. So I'm going to try to fix this best I can. It's never going to look quite right because it's not breaking clean. It's kind of like crumbling and there's no way to really fix it that well, but I'm going to try to do the best I can to reinforce this. What I'm going to do is just coat this entire thing in hot glue and kind of make it hopefully sturdier that way, because this isn't going to last this way. So, I mean, look at this whole thing, it's just broken right off. Not good. And then we're going to have to figure out how to screw it back on because these studs, right here, this one just broke right off when I went to unscrew it. This is not good at all. I covered this in glue. Hopefully I used enough. And this will secure the studs at least, I think. And it'll keep this in place. But this looks awful. It's a chunk missing and everything. So I'm not sure what to do about this. But that'll be a problem for the future because ultimately this fan is going to have to be revisited. The guards need to be redone. Okay, you can see here in the center where it's white and then it's got like a brown tint to it on the outside. The paint's coming off. There's some rust spots. So it needs to be repainted. You can see the rust pretty good on this side. So this is going to be a revisited project in the future. And when it gets revisited, I will try to do something about this badge. But for now, let's see if I can put it back on without it breaking, because it kept breaking as I was trying to take it apart. So hopefully I can get it back on without that happening. These screws are a little bit large in my opinion for these holes, and so that could be part of why it doesn't thread as nicely as it should. But these are the screws it came with, so we'll keep going with them even though I don't think they're quite right. Oh, for heaven's sakes. Even these bolts are kind of rusted. This must have been used in a very wet environment. That's back on. Looks awful, but it is what it is. Did the best I can. You know, it's turned into like powder at this point. There's only so much you can do with deteriorated plastic. The oscillating piece I think will be a little bit better. I have filled this up with the hot glue. I even got out the high temperature and filled it up with the high temperature glue. So that's drying now. You know, again, this looks awful, but it's deteriorating plastic. I can't fix that. So I'll set that aside for now, and let's continue reassembling, or start reassembling. Can't continue something you didn't start. There is hot glue strings all over the place here. Okay, this is totally secure, so I don't want any commentary about how you shouldn't reuse tie wraps. I'm going to put this on here. Those wires were kind of over in the corner like that. In fact, you know what we should do before I put it back together? We should plug it in and test it to make sure that it still works. Appears to be. Let's let it oscillate a little bit. That may be too tight. See, I don't like the way this is designed anymore, now that I'm seeing it work. Look at how the screw goes right into the wire there. And you can see that's how it's been for years, because it's all worn out. Seems to me like it should be tied back like that more. But no, it just goes right back into place. Now that's too tight. That's not a good design. And I'm probably never going to use it on the oscillations anyways, so I don't really care. But I would not use this on oscillations because although it hasn't worn through yet, eventually it will. And that can be very dangerous. Very few of these fans, these oscillating fans, are made correctly as far as that wire goes. And it's such a safety issue. I don't know why they can't quite get it right. Anyways, these wires were kind of down in there like that. And then this will slide over here. And we'll screw this in the back here. Gotta put that crazy bit back on. Okay. And I'm gonna go let that stuff dry for a little bit longer before we put that on. Could put the front on now. I shouldn't have tightened this all the way yet. There we go. Okay, that's good. Now we'll put it back on the base. The base is another thing that's going to have to be revisited. There's all sorts of marks around the outside of it. I started cleaning a segment of it with the Goo Gone, and it does come off, but it takes an extremely long amount of time. And I have too many other things to do today, so I'm not going to do that today. But at some point I'll have to revisit this to deal with the guard situation, so at that point I'll deal with this. Now I think I'm seeing how this worked. There's a little tab in there, and this probably went over the tab and then to the right, so this should go in and then turn to the left a bit, or to the right depending on how you look at it. So let's see Okay, if we do that and then does it turn? It turned and it stopped. So that's what should happen. And it even has a little marker there to indicate where it is. Okay. Up in the top here, we need to put that thing back in, that spring contraption. So we'll go ahead and do that. Okay, the springing contraption is in. And in that hole there, the other hole, that hole is where the spring on here goes in, and then that part there interfaces with that springy thing on the base. So this is pretty simple, and it doesn't fly apart, and it's easy to put back together. I like this tilt adjustment. This is good. This here is the next thing to break, because it's the brittle plastic, and I already heard it creaking before, so just barely snug. And actually, it doesn't need a lot to stay up at all. So I guess if I'm careful, maybe it'll be okay. This screwdriver I found out in the yard one day. No idea where it came from, no idea who it came from. It was just out there. Okay, so that's working. Now I think this is dried enough that I'll put it on. Okay, this may not go very well. There we go. Alright, that's going okay, I guess. Here I am all concerned about the blade. The blade was the least of their concerns. Everything else broke but the blades. Okay, here's the switch, which is also that brittle plastic, but it hasn't turned into the powdery material yet. So that's still good. It seems to be working. Let's turn this thing around. This piece should be metal, but it's not, it's the plastic. That's just barely gonna go on there, because that's brittle as well. And it's got some freedom to move, you know, which isn't really correct, but whatever. Okay, put the blade on. Take two. Okay, and now the front guard will go on. And I put this on wrong. Top is here. Durr. Oh well. Nothing about the front guard is correct anyways. I don't think it'll be an issue if it's not technically the way it's supposed to be. Yeah, it's on there just fine. Okay, so that, not happy with how that came out. And it really stinks too, because this was, I was pretty excited about finding this fan. I guess the only thing that's really irreparable is the logo, because I can clean up the base later and I can repaint the guard later, and those two things will be fine. But the logo is just spoiled. Maybe I can get a. I know I have blank ones of these somewhere. I could potentially get one of those and maybe find a picture of this fan and print it out and just stick it onto the blank one. I don't know. I feel like that would look less terrible than this does, because this just looks awful. Well, anyways, let's plug it in and see if the performance at least is not a disappointment. Okay, we'll start off on the low. And I don't want the oscillations on, because I think they're kind of dangerous. Oh, it's moving a lot of air. And it's hard to tell because the furnace is running, but I think it's pretty quiet. Nice. Okay, let's go to the medium. The medium is working. And lastly, the high, which is the fastest speed. Oh wow, that's really moving some air. That's pretty good. Okay, and now we'll turn it off and see how good the spin down is. Oh, now the furnace is off. Yeah, that's a very moderate noise level. Pretty quiet. Okay, back to high, and then we'll turn it off. Okay, the spin down time is good. And now we'll close out the video by listening to the startup sounds again. Hopefully the motor sounds a little bit healthier this time. It's got a pretty good startup sound for just a plastic blade stand fan. Okay, well that's there for this one. This one will be revisited sometime in the distant future.